Thank you so much for inviting me, Bernard. This work is joined with my student, Marty Chen. I believe he's in the audience as well. So just feel free to interrupt me if you have any clarification questions, and hopefully we'll have enough time to have Q&A after the presentation. So as you know, before the pandemic, most of universities at US would require students to submit their standardized test score when they apply for a college. These standardized tests could be SAT scores or ACT scores. They're nationally standard tests provided by College Board and other people. So you can see that's in 2017 and 2018, the vast majority of the top 100 schools have test required policy. Only a few of them would allow the test to be optional or completely ignore the test score, which we will call it test blind. However, as the pandemic started, a lot of students may have difficulty accessing the test location or have difficulty, less resources to do the standardized test as before. So during this period, many schools start to allow optional policy. So that means if you do not take the test or choose not to report your standardized test score, you will still be evaluated by the admission committee, and you may still be considered for scholarship and other financial aid. So initially, that was meant as accommodation for the difficulties during the pandemic period. However, as the pandemic subsided, those test optional policy stay in most of the schools. You can see by 2022, most of the top 100 schools actually have test optional, and quite a few have test blind, and only very few has test required. I believe MIT belonging to this test required group. A lot of schools belong to test optional, while University of California schools are in test blind. Very interestingly, if we fast forward to 2024, last year, then some schools, especially elite schools, have started to reinstate tests required. So Yale has announced to require standardized test score for admissions. Brown did the same thing. Dartmouth, even UT Austin reverts back to tests required. And some of them cite the following reasons for this reinstatation. One is that they believe the test optional policy may have harmed the students from lower income families, especially those who are from low income families, but actually have good test scores in standardized test. There are also research from Brown, I believe from Dartmouth, their own admission data, they show that the test scores actually have good prediction power in students' college performance, even after we control for other observables in students' application file. So these are the reasons for those schools choose to go back to test required. At the same time, there are also schools who insist that they will be test blind or test optional. So University of California, they take the extreme position that they don't even accept any submission of SAT and ACT scores. They're not going to include such scores in their consideration of admission and scholarship, while the University of Michigan insists that they're going to solidify test optional policy, even if other schools go back to test required. So this is very interesting setting for disclosure, because students may or may not have test scores. They may or may not have the option to disclose their test scores. The crucial question here is how the school is going to interpret non-reporting from the student. When we started this research, I have my second child in this college admission stage. So we had the opportunity to visit a lot of schools. Almost in every Q&A session, there will be a question from applicants asking how you're going to interpret the non-reporting status. It's very interesting that almost all schools in choosing the test optional policy would say, okay, rest assured that you are not going to be disadvantaged if you choose not to report your score, and we'll consider your application in a holistic full file review, taking into account every information you give us. So in other words, you cannot get a very clear answer from how they're going to interpret the non-reporting score. It's interestingly, if you look at the data, the trend of reporting rate has gone down from about 70% to about 40% during this period. Okay. And if you look at the score distribution conditional on those who have reported the scores, the distribution basically shift to the right. On the left, we're showing the 25th and 75th percentile of reported SAT score in the top 100 schools, as reported by Department of Education and US News. You can see that's after most of the schools adopt test optional. You can see there's an increase in the 25th percentile and the 75th percentile of reported scores. Okay, and same trend occur for ACT. This is again conditional on the schools, conditional on the admitted students who choose to report to the schools. So by far, you probably realize that what I described is completely in conflict with the classical disclosure theory. The disclosure theory would say that we should have unraveling. The school should assume all the non-reported students to have the worst test scores, and therefore all students except those who have the worst scores should choose to report. In reality, we only observe about 40% of students reporting, okay? And the schools, as they claimed, they want to assure students that they're not going to be skeptical about non-reporting. In other words, they try to confirm the students that they're not going to adopt the unraveling assumption of non-reporting as the theory dictates. And at the same time, tons of educational economists have shown that standardized test scores actually help to predict students' academic performance in college and even after college career success. This is after controlling for other observable students' attributes in student applications. Okay, so in other words, it seems like standard tests contain some useful information. However, schools are moving towards test optional or test blind, and they're not skeptical enough, at least compared to the theory about the non-reporting status. And consistently, we observe students, over half of the students choose not to report the score, or maybe they haven't taken the test and therefore do not have a score. So this is a very interesting setting, and we want to understand the incentives and the consequences of such voluntary reporting. In particular, we asked the following 3 research questions. The first is, given this environment, how would students choose to report or not report their standardized test scores? In particular, we want to emphasize that the students may have private information. You can think of private information as SAT or ACT scores. At the same time, they may also have public information, so that public information could be other materials they have to fill out in the application forms. And the schools have certain interpretation of the non-reporting status. So that's the first question. We want to understand the reporting decision of students. The second question is, how would such strategic reporting behavior of students affect colleges' admission outcomes? In particular, we want to consider 2 outcomes. One is what we call academic preparedness. Okay, so that's the average, we can think of that as average merit of students' academic performance. And the second is the diversity of admitted students. This could be some diversity based on their family or economic background and racial and other demographics and so forth. So that's the second question. And the third question is, given what we observe in the data, how should a college choose among test required, test blind, or test optional? So to answer those questions, we're going to use lab experiments because it's going to be impossible to have representative real world data and covering all types of schools. Okay, so we have 3 findings. The first is, as we have observed and expected, voluntary disclosure is incomplete and selective. In particular, if a student's private information is more favorable, the student is more likely to disclose that information. However, if the public information is more favorable, the student's actually going to withhold their private information. If the school is less lenient in non-disclosure, then students will be more likely to disclose. And across 50 rounds of our lab experiments, we can show you that subjects learn, but they do not discover the exact school admission policy. At the start of the research, we were thinking there got to be some trade-off between the academic preparedness and the diversity of admitted cohort. It turns out that, at least in our setting, we don't see much of such trade-off because test blind is actually worse in both dimensions, and test required is better in both dimensions than the majority of test optional policies. At the same time, we do see a few test optional policies that could achieve higher diversity than test required. And that's mostly because students do not have perfect information about how the schools interpret the non-reporting. In our simulation, if the students fully understand the actual interpretation of non-reporting, we can show that test required actually dominate all test optional in both dimensions. So this leads us to say, okay, how come we still observe some schools adopt test optional? What are they trying to achieve? So we try to extend our model. At the end of the paper, we considered, for example, what if some students will find it very costly to take the test, and therefore they cannot submit application to test required schools because they do not have a test score. In that case, we can show you that under some very costly situation for students with resource constraint, some test optional policies could lead to more diversity. Another situation is if the SAT or ACT scores turns out to be very noisy and do not provide much information as compared to the other public information the school would have known from the students, for example, the high school GPAs, then we can show in that case, the test optional could have some diversity, could have more diversity than tests required. So these are the 2 situations we can find in the extended model that somewhat justify the test optional. But overall, the logic is sort of showing that test required should have achieved better outcome in both dimensions than test blind and most of the test optional situation. Tim, you had a question.
Yeah, just out of curiosity. So when we look at these, or when you look at these schools, do you assume that these schools, like in your experiment, have all the same objective functions? So would, like, if we put that to reality, would a small state school have the same objective function as Berkeley or Stanford?
Yes, that's a fair question. We actually do not take a particular position on exactly what the objective function is for the school. We'll show you both dimensions, and when we say test required dominate other policies, that means the test required actually have better outcome in both dimensions, regardless of how you trade off those 2, as long as you appreciate both.
Okay.
Daniel?
Just really quickly, and you may have said this already, did the number of students taking tests go down in the actual data? Because you were describing the potential problem. I was just wondering if it shows up.
I believe so. Yeah, I believe so. But I mean, again, this could be a strategic option, right? Given the test optional policy rather than just because of resource constraint. Yeah, these are good questions. So our work related to 2 literature, I think most of you are probably familiar with the voluntary disclosure literature in the IO or accounting context. In the education economics context, there are tons of literature try to show the correlation between standardized test and the college admissions. given the test optional policies, some studies have shown that test optional actually have mixed effects on the amount of application volumes received by schools, as well as on the diversity of enrolled students. There's some evidence, I believe this is a study based on College Board data. They show that students are somewhat strategic when they choose what to report. And the SAT scores are more likely to be reported if the scores are higher. There are also some theoretical literature ongoing, try to consider, okay, when it could be actually desirable to have a test optional policy. So one reason they have found is, for example, endogenous test taking. If the students may have some resource difficulty in taking the test, well, test required would kind of disallow such students to apply for the school. That could be a disadvantage of test required as compared to test blind or test optional. There are also studies try to show that test optional may be a strategic choice by the higher education institution because they have different preference as compared to the society. And this is a way that they try to accommodate the social pressure. There are other, the third theory paper showing that's excluding the test scores could be welfare reducing. So these are all theoretical work. Well, hopefully our work get closer to the reality by running lab experiments with real student subjects. Okay, so before I show you the experimental results, I want to fix the idea with a very simple college application problem. So we make it as simple as possible to still contain the key information components in the game. So imagine that we have a college, there are N students applicants, and each student would have a private endowment A, that could be a standardized test score. They also have a public endowment B, you can consider that as their family background or high school GPA. The students know both A and B, and everybody knows that A and B are positively correlated. So here you can think of alpha as the correlation between those two information, while E is the extra information about the applicants that's contained in A, but not captured in B. And then the college want to only admit the best half of the applicants, and the admission will be based on the total endowment. So if A is reported, the college observe both A and B. The college can have, you can think of this as a objective or utility function of the college for the students, that will be just A plus B. If the A is not reported, the college is going to take a guess of A condition on the B it observes. So let's assume the college guess is a function of the B and something else. So given that the college know A and B are correlated with this actual alpha, then the guess of A would dependent on B, but also have a constant. So here the constant C can be interpreted as the degree of leniency in the school's interpretation of non-reporting, regardless of the reported B. Okay, and then it's, if everybody has perfect information, then the students, or rational students, would have such strategic behavior so that she would only report the A if the new information contained in the A is bigger than the average leniency the school has for the non-reported students. Does that make sense? Okay, so this is a very simple rule for a rational student who knows everything of the A's, the additional information A and B, and the school's interpretation. Yes, Robert, you have a question?
Yes. So it's super interesting. So I was just curious, do you know, are the test takers who reveal their scores but have low scores among the disclosures, are they actually punished compared to the non-disclosures?
I'm going to show you the results. I'm going to show you the results.
Okay. Well, I mean, empirically, like in
Yes,
you
yes,
know,
yes.
because empirically in actual data in the real
Yes.
world. Wow.
Oh,
Okay.
in the real world, you mean the not in our experiment, but in the actual reported scores?
Yes, yes.
Yeah, we don't have the College Board data, but a previous study I cited in the last slides, they have used the College Board data. They show their strategic behavior in terms of higher score students are more likely to report the score. Okay, so so this model actually, this very simple rule that you're going to report if E is bigger than C would actually suggest two incentives. One is the partial unraveling, that's as Robert has alluded to. If your score is higher, conditional on B and C, you're more likely to report. Okay, if you know the school is going to be lenient on the non-reporting, you're less likely to report. So that's very intuitive. Another incentive, which we will call it reverse unraveling, it may not be that obvious, but it's also interesting. So because the school's interpretation depends on B, given the positive correlation between A and B. So this means conditional on your private score and conditional on the general leniency level, the higher your public information is, the less likely you're going to report. And that's because the school is going to have a better interpretation of your non-reporting status if your B is higher. Okay, and this incentive is so strong. When my daughter and I talked to a counselor in this area before she applied for college, the counselor basically gave us the following shocking suggestion. She said that given your zip code, given her high school, given your race, and many other information, we recommend you not reporting your SAT score unless it's above 1550. 1550 is the 99 percentile of SAT score. Okay, this is a crazy suggestion. Given I have worked in this area and I was very in strong belief of the unraveling theory, I was really shocked by the suggestion. This is literally a reverse unraveling. Okay, how could that happen? That's actually what motivated us to start this research. But once we sketch out the model, you can see there's indeed such an incentive. If your B is so high and the school tend to give lenient interpretation of your non-reporting status, given your B, you actually would have less incentive to report. Okay, so putting this two together, you can see that the two incentives actually running against each other. If you have a very high B, and most likely you're going to have a high A, so the partial unraveling would motivate you to review your score. On the other hand, if you have a very high B, the school tend to have a good interpretation of your non-reporting status, which actually going to discourage you from reporting. Okay, so keep that in mind as we show you how this panned out in our experiment. And if you put this theoretical model together, we can show you how the test required, test blind, and test optional compare to each other in the admission outcome. So in this picture, I'm showing you two dimensions. B is the public information, and E is the new information contained in A. Okay, let's assume these two dimensions has a uniform independent distribution of 0 to 1. Okay, so the applicants are randomly dispersed in the square. This point is the best student, right? It has the highest E and highest B. Obviously, the college want to admit such student. And assuming the school cares about both E and B, there will be a trade-off between how the schools think about the relative importance of E and B. Okay, that depends on the correlation between A and B, which is alpha. Okay, so basically you can imagine the school has a indifference curve at this slope. Okay, it's going to go down this direction until it admits half of the students. In the test required, that's very easy because everything is observable to the school. So they would just admit the first half, okay, as the shaded area here. In the test blind, because the school actually observed nothing about E, the only information to the school is B. So the school have to go this way and admit the first half, which has the highest B. Okay, so that would be this shaded area. If it's a test optional, remember the strategic reporting decision is you're not going to report until E is bigger than C. So you're only going to report in the top half of this picture. So that means when the student, when the college have an admission policy, is going to choose the half in the shaded way that's will have this kinked indifference curve. Okay, hi Tim.
So just to be clear, the option 3, the test optional, that's the one that the counselor suggested to you, right? With the 1550, right?
Right, right. I mean, if you're thinking that we have relatively high B here, right?
Yeah.
And this basically saying that's we probably don't need to report because we're going to be admitted anyway.
Okay.
Okay, so just compare the 3 pictures, right? As you can see in the test required, it's the school can approach pretty high E here, even if the students have a low B. Well, here, because the school's hands has been tied, it won't be able to achieve, it won't be able to reach those high achieving but low B students. Okay, and as a result, the average E is lower for test blind, and also the diversity of admitted students are lower as well because they don't even have a chance to reach those low B but high achieving students, because B is the only information and B is supposed to suggest some of the A. So they end up admitting only those high B students. Okay, and test optional will be somewhere in between. And this will be even clearer. Okay. This will be even clearer if we just compared to, say, we compare test required versus test blind. The test required basically is going to admit the green area and ignore the yellow area here, where the test blind is the reverse. Okay, so you can see every point in the green area is actually better in terms of the school's objective function than every point in the yellow area. And similar logic apply here if you compare the test required versus test optional, or you compare the harsher test required versus more lenient, the harsher test optional versus more lenient test optional. Okay, so this actually gives us a very clean theoretical prediction that we should have test required, completely Pareto dominant, harsh test optional, dominate lenient test optional, and dominate test blind. And you may argue, okay, what if we have quota by different types of B? We can show the same logic. Basically, the same logic applies for every type of B. Okay, in the interest of time, let me proceed. So you may say, okay, your theory is too simple. You assume everybody have perfect information and everybody act rationally. You assume both schools and students have perfect information about the correlation between A and B, okay? And those assumptions may not hold in reality. So that's why we run a lab experiment. We want to relax those assumptions, allow some degree of bounded rationality for the students, allow students have imperfect information about the school's admission policy. Okay, so if we sort of extend this with those relaxed assumption, again, we can think of the school try to admit the better half. And if A is reported to school, it's going to look at A plus B. If A is not reported, we assume the school's belief will be somewhat depends on B with probability of alpha. Okay, with probability of alpha, the guess will be exactly B. With the another probability 1 minus alpha, the belief maybe depends on the statistics of the last round of admission. Okay, this is trying to mimic the US news situation. That's X here indicate the 25th percentile of admitted students A. Okay, well, the Y here indicate the 75th percentile of the admitted students A. Okay, so in other words, in this simple setting, we can use 4 parameters to categorize a school's policy. So alpha is how much dependence you think the A is on B, while the gamma 0, gamma 1, and gamma 2 indicates how you interpret non-reporting, not conditional on B, while incorporating the last cohort's admission statistics. Okay, and of course, students may not fully understand those policies. So we allow the students to have a belief on alpha that could depart from the actual alpha. We also assume the students could have some belief in gamma 0, gamma 1, and gamma 2, and they could be different from the school's real admission policy. Okay, and if the student is irrational, the reporting decision is very simple. It's only going to, he's only going to report if the actual A is bigger than the expected A based on the school's admission policy, or based on the student perceived school admission policy. And here we also allow some risk attitude difference across students. So this term is try to capture the risk attitude. So in our experiment, we assume A could be any random number between 1 and 5, and B could be 1, 3, or 5. We set it up so that the correlation between the two is 0.5. And the students observe A and B. It also observes some admission statistics of the admitted cohorts from the last round. So that's literally the 25th percentile and the 75th percentile of the reported A, and the mean of B for admitted students. And the subjects choose between disclosure or not disclosure on A. B is always observable to the school. And we do not have any player play the school. We basically have a computer simulating the school, okay? And the computer is going to rank the subjects according to the alpha, gamma 0, gamma 1, gamma 2 we give to the computer. And then the computer makes such a rank, admit the top half, and the students observe their own admission outcome. So the experiment interface, before I talk about interface, I should talk about the treatments, okay? So to some extent, the students are in the dark because they don't know exactly what algorithm we give to the computer. We run 2 treatments by varying the algorithm in the computer simulated admission policy. T1 is relatively harsh one. We're basically saying that, okay, the school is going to assign the interpretation of non-reported A as B with probability of half. For the other half, the school going to interpret the non-reporting as half of the 25th percentile. So this is sort of relatively harsh, right? We believe your actual A is even below the 25th percentile of the last round. While in T2, the school is relatively lenient, going to interpret the non-reporting status as somewhere an average between the 25th and the 75th percentile of last admitted cohort. Okay, so in other words, we can describe T1 and T2 as those parameters as in our model. Okay, so this is how the subjects look at the results. We told the students was the 25th percentile of the endowment from the last round, was the 75th percentile, was the average value of endowment B for admitted students. And then we say, okay, in this round, your endowment A is this, your endowment B is this, and you can choose to report or not to report. And after your choice of reporting, you will receive your admission outcome. So in this case, the student is rejected. Okay, so we run this in our lab with 16 subjects per session. Each student plays this game for 50 rounds. We choose 2 random rounds at the end for payment. We pay a show-up fee of $10. Other payment is conditional on the performance in those 2 random rounds. If the student get admitted, they will receive $6. So if the student got admitted in both rounds, she can receive $12. We also have some risk aversion question with incentive compatible payment there. So overall, we observe some dispersion of the payment. The average is about $18. We run this for 18 main sessions with 285 subjects. Okay, so let me show you some statistics. I think there was some question about the reporting strategy. I hope this will give you a sense of that. So this basically is a reporting table. Every number here is the percentage of students choosing to report their private information A. So the first panel give you the summary by the A's, okay? And if you look at if you look at these 2 columns, you can see we see very strong partial unraveling incentive. The higher your A, the more likely you're going to disclose. Okay. More interestingly, if you look at these 2 highlighted box, you can see that in the harsher treatment, if you are somewhat a median student, you actually choose to report more as you go through the rounds. Okay, remember T1 is the relatively harsh admission policy. In comparison, in T2, this is a relatively lenient admission policy. We actually see the subjects learn to withhold their information over time. Okay, and if you look at by B, I told you before that there's this partial unraveling, there's this reverse unraveling, and these two may counter each other. For the very high B students, because their B is so high, their A is also high, okay? So they're very likely to report. However, if you look at the very low B students and mediocre B students, the relationship here is not monotonic, okay? For B equal to 3, they actually tends to report less than even B equal to 1, despite the fact that their A is on average better than those of B equal to 1. Okay, this is particularly true for the lenient situation as the B equal to 3 students learn to withhold their information over time. And if you look at the dynamics in this harsh treatment, basically we don't see much change over time. But in the lenient treatment, this line is going down. Okay, the vertical axis is the reporting rate. This line is going down, and this line corresponding to B equal to 3. So that's like a median student with an average public information. If you put these two pictures together, you can see the contrast between those two treatments for B equal to 3. They're not exactly as our theory predicts. Our theory basically saying that in the harsh situation, almost all the B equal to 3 students should disclose their score. In the lenient situation, almost all the B equal to 3 students should withhold their information. Okay, we don't see as stark difference as a theory predicts, but we do see a significant difference in our experiment. If you look at each cohort, if you look at each B cohort separately, for B equal to 1, our theory predicts that the margin is when your A equal to 2. In particular, the theory predicts that if your A is equal to 2 and your B is equal to 1, you should always report your A if the school is harsh, and not reporting it if the school is lenient. Okay, so we see some slight difference, but not as stark as the theory predicts. For B equal to 3, the theory predicts the margin is here for A equal to 3. If your A is equal to 3, the theory predicts that you should 100% report your A if your B is equal to 3, but you should completely withhold your A if you're in this lenient situation. And you see a big difference in our experiment subjects, but not as stark as the theory predicts. And for those very high B students, the theory predicts the margin is on 4. That's in the harsh situation, every 4 should report. Every 4, and in the lenient situation, every 4 should withhold. And again, we see some difference in our experimental results, but not as stark as in the theory. Okay, so that's kind of our experimental results. We try to put this in a structural model so that we can run some counterfactual simulation in other test optional situations that we haven't done in experiments. So in particular, we try to model the students' reporting decision. Okay, so again, the student should report if the utility they expect from reporting is higher than what they would expect, conditional on their interpretation of the school's interpretation of non-reporting. Okay. And we try to estimate this structural model in 2 approaches. The first one is what we call a heuristic model. We're basically saying, okay, maybe your reporting decision, given that you don't know the exact admission policy of the school, your reporting decision will based on the information you have received so far. And that information could be whether you have reported under the same private information before, whether you have reported under the same public information before, what's the admission outcome for you in those situations. So that's kind of the individual specific history in your play. So that's a heuristic model. And the second one, we put more structure of Bayesian updating, assuming that you think the schools could have 625 school policies possibility, and then you have a prior on each one of them, and over the place, you try to update your belief in the Bayesian fashion. So you will become more and more aware of the school's actual policy based on the outcome you observe. Okay, so here we're showing you the fit of the model. The bars are the actual data, okay? The lines are our prediction from the heuristic approach or from the Bayesian updating approach. You can see both try to mimic the reality fairly well, but actually the heuristic model did a better fit than the Bayesian updating model. In particular, if you look at our heuristic model estimation, we run it for all rounds for the latter 30 rounds. We include the subject's caveats or include the subject's fixed effects. So the one that I highlight here will be the final results we use for the counterfactual simulation, mostly because we cannot predict what the counterfactual subject fixed effects would be in our simulations, but we can have the subject's covariates by randomly drawing from our existing subject pool. Okay, so basically the result is pretty sensible. That's if your public endowment is very high, you're less likely to report. If the last round's 25th percentile is very high, and then you tend to withhold your information. Okay. While the Bayesian model does not give us as good a fit as the heuristic model, it's still very interesting to look at the results. What we find is it seems like the students have this prior that they think that the interpretation of the school for non-reporting will be correlated with a B, but it will be relatively lenient, okay? And then in this harsh treatment over time, they learn that's okay, they may be harsher, the school may be harsher than the prior, and they put more weight on the dependence of B. While in the lenient situation, the subjects actually learn that the school is more lenient than their prior, and the school seems to have more dependence on the B. So this is very consistent with the actual data we observe. So with all these structural estimations, we can simulate different test optional situations. So T1 and T2 are the two that we tried in our lab experiments. We can think of many other test optional situations with different parameters on the alphas and on the gammas. To illustrate what those counterfactual mean, if you're thinking a student has an average B and the student test score is well, it doesn't depend on student test score. If the student have a B in the B equal to 3 in the public information, and the last rounds, the 25th percentile of reported A is 4 and 4.5 for the 75th percentile, then those different counterfactual test optional would describe different school beliefs on this, okay? So these two, the C3 and C8, basically saying that's the school is going to be relatively harsh in interpreting the non-reported A, conditional on B equal to 3. Well, point here means the schools is going to be very lenient for those non-reported status, conditional on B equal to 3. Okay, so the different counterfactual situation here give us different level of leniency in test optional. Here's our simulation results. So on the vertical axis, we're showing you the average of private endowment conditional admitted students. Okay, and on the horizontal axis, we're showing you the standard deviation of public endowment of admitted students. So this meant to capture diversity, and this meant to capture the average academic preparedness. Okay, so test required is here, and test blind is here. So you can see test required dominate test blind in both dimensions, regardless how the school have a trade-off in their objective function between those two dimensions. And T1 is here and T2 is here. Most of other test optionals are somewhere in between, okay? We do observe a few exceptions. So those exceptions, remember, these are the harsh test optional policies, okay? And they seems to give us a better diversity as compared to test required. this is mostly driven by the students do not have perfect information about the school's actual admission policy. In our simulation, if we assume students have perfect information of the school's actual admission policy, you will see this picture. Okay, the test required dominate not only test blind, but also every test optional simulation we have. So this is how I answered the previous question. It actually does not depend on how the objective function of the schools has a trade-off between those two dimensions. Our results shows that test required is the best. Okay, and test optional are better than test blind. Why we observe those two exceptions? Okay, and remember these are the harsh interpretation of non-reporting. It turns out that that's because students are not aware of the severe punishment in the school's admission policy. And therefore, some mediocre students end up not reporting their A because of reverse unraveling. Okay. For example, if you look at those two students, the mediocre students have B equal to 3 and the test score equal to 2. Okay. Suppose the actual interpretation is 1.5 by the school. The students, if have perfect information, should have reported A, okay? But if the student does not anticipate the A bar to be 1.5, this student may choose not to report. However, another student with B equal to 1, but A equal to 4 has reported. So this student will look better than this student conditioned on the student 2 has not reported because of imperfect information. So as a result, the diversity could increase in test optional as compared to test required. Okay, so we also did a few extensions. For example, in this extension, we admit the reality that, okay, maybe those students with low Bs would have resource constraints so that they cannot take the test. So we try 3 versions. So the first version, we're saying only 50% of the B equal to 1 students are able to take the test. In the second situation, we say only 1/3 of them are able to take the test. And then in extreme third situation, we're saying everybody in this B equal to 1 situation would not be able to take the test. And then we run the same simulation as before. So you can see that once we sort of tie the hands of tests required, especially in this situation, because no students with B equal to 1 will be able to take the test, they're automatically out of the picture for test required. So that explains why in this very strict test taking situation, that's the test required is actually worse than test blind in the diversity. Okay, but in all the other situations, the test required is still dominating test blind in both situations. The second extension we did is saying, okay, maybe the test score is not the only way the school can understand the student's academic preparedness. The school actually can observe the student's high school GPA. Maybe that's a good enough proxy. Okay, so here the extension would allow 2 public information, B1 and B2, while A is still private information. And if we're thinking the merit based on A and B1, but not based on B2, okay, then we can show the same logic as before. That's in the test required situation. Suppose the school observe A, B1, and B2, that would allow the school to have perfectly identified M, then that's the same picture as before. They're going to admit the first half students, okay? Well, in the test optional or test blind, they may not observe the A until the student choose to report. So that's some noise in the A, okay? So because of that noise, they may end up making mistakes. So these are the students who have actually high merit, but maybe mistakenly thought to have low merit. So some of them may end up not being admitted. So these are the students here. Well, on the other hand, there could be some students who actually have low merit, but their reported A and their B1 may signal that they have high merit mistakenly, then they could be admitted, okay? So in the test optional and test blind situation, it may end up rejecting those students that should have been admitted and accepting these students that should have been denied. You can see every mistakenly rejected students could be better than every mistakenly accepted student. So that would be the same argument as before, this would have a compromise in the merit of admitted situation, okay? But this actually give us a, I guess, ambiguous prediction on exactly how the diversity on the B2 would pan out, given those mistakes. It probably depends on exactly how the mistake would happen. So given this, we run the simulation. We're saying, okay, let's say we observe, we as a computer observe the actual merit, but we simulate B1 and A with some noise, okay? And the probability of the noise can be indicated by PA and PB. And then we allow the students to admit based on the observed B2 and based on their anticipated merit, conditional on the reported A and conditional on the B1. Okay, and then we run the same simulation as before. So you can see here that's if SAT score is relatively informative, then we have a picture similar to before, except that in those super harsh test optional situation that we could observe more diversity, as I explained before. But if the SAT score is not that informative, you can see the test required and test blind are very close to each other. That's because the extra information contained in the standardized score could be very low. And then the test optional could give us more diversity as compared to test required. So in conclusion, what we find is if we stick with a simple model of school admission outcome, then we can show you that test required always dominate test optional, and test optional always dominate test blind, regardless of how the school's objective function is on those two dimensions of admission. Our lab experiment largely confirmed our theoretical results. We show that the voluntary disclosure is incomplete and selective. There's evidence for both partial unraveling and reverse unraveling. And the subjects learn about the school's admission policy, although they do not fully recover the exact admission policy. And our structural simulation confirmed the theory insights that test required and test optional are always better than test blind. In some situations, the test optional may give us more diversity, but still lower academic preparedness as compared to test required. And those situations happen if the students have imperfect information about how the school is going to interpret non-reporting, if the test taking is very costly for students with low family background in their public endowment, and if the SAT scores are very noisy and do not provide much new information as compared to other public information already observable to the school. So that's basically our findings. I'm happy to feed any question and comment.